Hi everyone, this is Jesse Seldis from Cockroach Labs. I'm going to be running through a demonstration of how easy it is to deploy CockroachDB across different cloud platforms, and then how easy it is to migrate all data from one cloud platform to another while the cluster is under load with no service interruption or downtime at all. And here's the basic setup. We're going to have 3 CockroachDB nodes on GCE and 3 nodes on DigitalOcean. The nodes on GCE are going to have the locality flag specifying that they're on GCE, and likewise the nodes on DigitalOcean will have the locality flag specifying that they are on DigitalOcean. This will tell CockroachDB that all replicas should be balanced across these 2 clouds, and we'll look at the admin UI and see that that is the case when the time comes. In front of the cluster, we're going to run the open source HAProxy load balancer. That's going to be on a separate VM on DigitalOcean. And then on my local computer, I'm going to run our version of the YCSB load generator, which is going to simulate 50 concurrent client workloads, each writing 5% and reading 95%. And that's going to be pointing at the HAProxy load balancer, which is going to distribute the client workloads across the cluster. So I've already done some of the initial setup. I've created 4 VMs on DigitalOcean, again 3 for the nodes, 1 for HAProxy, and I've set up 3 VMs on GCE. This is going to be a completely insecure demo. DigitalOcean is completely open already. GCE, I needed to create some inbound and outbound firewall rules to allow all traffic on certain ports that CockroachDB expects to communicate on, 26257 for internode communication, and 8080 so we can access admin UIs. And on the DigitalOcean VMs, I've also installed NTP. CockroachDB requires moderately accurate clocks. GCE already runs clock synchronization, but we want to make sure we're running that on the DigitalOcean VMs, so that's already there. I've also already installed the Cockroach binary on all the relevant VMs on GCE and DigitalOcean. So at this point, I've SSH'd into each VM. We're going to start with the DigitalOcean VMs. I'm going to start with the very first node. So I'm going to execute the cockroach start command in insecure mode, and it's basically advertising this VM's address, and again it's specifying the locality flag saying that this node is on DigitalOcean. So let's do that. Okay, so we can see if we look at the status field that we've initialized a new cluster. We have a cluster ID. This is node 1. So now I'm going to start the second node on DigitalOcean. The command is almost identical here. Again, I'm just executing the start command, insecure, advertising this VM's address. The new flag here is the join flag, where I'm specifying the address of the first node, and this is the way in which a new node knows it's joining an existing cluster. And again, I'm passing the locality flag saying that this node is on DigitalOcean. So let's do that. Okay, so if we look at the status field again, we can see that we initialized a new node, but we joined a pre-existing cluster. So if we look at the cluster ID for node 1, it's the same as the cluster ID for node 2. And we're going to do the same thing again for the third node. Again, status, initialize new node, join pre-existing cluster, same cluster ID. This time we see that the node ID is 3. Okay, so now I'm going to do the same thing on the GCE VMs. So I'm SSH into the first VM on GCE. The commands are going to be the same as before. The only difference is that we're changing the locality flag to state that this node is not on DigitalOcean, but rather on GCE. Okay, real quickly, we see the status again. It has joined the cluster. It's considered node 4 of the cluster. Everything's good. And it's worth stopping and noting that with this node, our cluster has now been deployed across two distinct cloud platforms, DigitalOcean and GCE. So we're going to do the same thing for the second node on GCE. Okay, so this is now the fifth node that we've added, and we're going to do the same thing for the sixth and last node. Okay, so we're adding the sixth node. There we go. Okay, I'm going to pull up the admin UI and take a quick look. This is a completely insecure cluster, so the admin UI is accessible at the address of any node on port 8080. And so here's the address of the first node, port 8080. Okay, so we're going to go view the list of nodes, and here we see that there are 6 nodes. The first 3 are on DigitalOcean, the second 3 are on GCE, and we haven't added any data yet, but you can see that the replicas, the initial replicas, are pretty much even across all nodes. That's again due to how we set the locality flag when we started the nodes. And we can go down to the replicas per node graph here, and we can see that all replicas were initially on the first 3 nodes. The replica count was higher initially, but once the second 3 nodes were added, the replica count went down because they were being balanced across all nodes. And at this point, again, the count is pretty much even. The count on hover is a little bit behind, but you can see the graph represents or shows that the number of replicas on all of the nodes are pretty much even, and that hover text will catch up in a few minutes. Okay, so let's start up HAProxy now. We've already installed HAProxy. We've also already installed the CockroachDB binary because CockroachDB has a built-in command to generate an HAProxy config file that works with the running CockroachDB cluster, so it's pretty easy. So we're going to run the command to generate that config file. So it's just cockroach gen HAProxy. It's insecure. For host, we just have to specify the address of any node in the running cluster. In this case, we're specifying the address of the first node. So let's run that. And we can see that an HAProxy config file was generated. Let's take a look at it. Great, so the important thing to note here is that the address of each CockroachDB node is listed under in the listen pSQL section. HAProxy is going to use those addresses to make sure that client connections are balanced in a round-robin fashion. So it's going to go from one node to the next for each new connection. Okay, so let's start up HAProxy. Great. So next we're going to start the YCSB load generator. I've already installed it locally, so I'm going to copy this command to a new terminal. So this is on my local machine. What we're going to do is run the load generator for 2 hours with 50 client workloads running concurrently, each of them writing about 5%, reading about 95%. But before that starts, we're going to split the initial ranges of the cluster so we can better visualize rebalancing across the cluster, across nodes. And we're going to do an initial sequential insert of 500 rows. And the connection string here points to the HA proxy server. So let's do that. And now let's go back to the admin UI. So at first, we're not going to see any SQL queries, but we will see the ranges splitting. So if we go back down to the replicas per node graph, we'll see the replicas, the replica count going way up on all the nodes. And this is the initial splitting that's happening. We should be able to see here that there's a bunch of initial inserts that are happening. Those are the 500 rows that are being inserted. Let's go to the SQL dashboard, and we can see that the client connections are sort of ramping up. And at this point, there are 50 concurrent clients connected to the cluster. If we go back to the overview, the cluster overview dashboard, we can see now that there are, around 95% of the SQL queries are reads, and something around 5% are inserts, are writes. And finally, let's go back down. Let's look at the replicas per node. Everything has evened out. The replica count is pretty much even on all the nodes. We can look at the view nodes list again, and we can see here as well that the replica count is pretty even across the entire cluster. And this basically tells us that we're balanced across these two clouds, DigitalOcean and GCE. So we could let the load generator just continue running and let the data size increase. But what I want to show you now is how easy it is to move data from one cloud platform to another with a single command, and do so while the cluster is under a lot of load. Remember, YCSB is basically has 50 concurrent connections open against the cluster right now. So we're in another terminal. I'm on my local machine again. I have Cockroach installed locally. What I'm going to do here is run the cockroach zone command, pointing it at, in this case, the first node of the cluster, but it could be any node of the cluster. And I'm going to put in place a hard constraint saying that all replicas are required to be on nodes with the locality flag set to cloud equals GCE. So you remember that the DigitalOcean nodes all have cloud equals DigitalOcean, cloud equals DO, and the GCE nodes all have cloud equals GCE. So essentially we're going to force the data to migrate to the GCE nodes. So let's execute this command. Okay, and it just printed out the cluster-wide zone configuration, and we can see that the new constraint is in place. So if we go back to the admin UI, and we look at the replicas per node graph, very quickly we're going to see the replica count double on the 3 GCE nodes and eventually go to 0 on the 3 DigitalOcean nodes. And you can already see the split in this graph. And if we go to the node list, we can already see that happening as well. It looks like it's 0 on the DigitalOcean nodes here already. Okay, so at this point, no data remains on the DigitalOcean nodes. All the data has been migrated to the GCE nodes. So this was a full cloud migration executed with a single command in less than a minute. Now to further drive home how easy this is, let's do the opposite. Let's change the hard constraint to require that all data be on the DigitalOcean nodes instead of the GCE nodes. Okay, so again, we're looking at the cluster-wide zone configuration, and we can see that the constraint has been updated. The hard constraint is now stating that all data must be on nodes with locality set to cloud equals DigitalOcean. So let's go back to the admin UI. And again, very quickly, we can see that replicas are rebalancing in the opposite direction. So we can look at the node list again and see the same thing, that the replica count is now, it used to be 0 on DigitalOcean, and now the replica count is going up and it's going down on the GCE nodes. And already, all the data has been migrated to the DigitalOcean nodes. None of the data remains on the GCE nodes. So twice we've shown how to migrate completely off one cloud and onto another. And that's what I wanted to show you today.